right, let's review 4.1 through 4.3. Okay, starting with number 1, we have to kind of look at these graphs and identify if it's a function, then if its inverse is a function, and if it's one-to-one. So first, to find if a graph is a function, that's going to be the vertical line test. So if I was to draw vertical lines through this function, it will only hit that function. Any vertical line I draw is only going to hit once. I could cut this up into tiny pieces and it will only hit once. So yes, it's a function. If I was to draw the inverse of this function, my graph is going to, remember, it's going to rotate about the y equals x axis. So it's going to kind of change and look, this isn't going to be perfect, but I'll just kind of draw basic. That's what the function would somewhat look like. Now, if I need to find out if that's a function, again, I'm using the vertical line test and drawing through here. If I was to draw a vertical line through this, it's hitting 1, 2, 3 times. So no, the inverse is not a function. So is this function one-to-one? No, it has got to be a function, and the inverse has to also be a function in order to be one-to-one. Right? And then if we look at B, here's a line. Yes, that will definitely pass the vertical line test. If I was to draw the inverse, yes, that's going to be the inverse is also a function. It's just going to kind of flip on the y equals x axis. And so yes, it is one-to-one because it is a function and its inverse is a function. So for number 2, you need to look at the points that each of these points are at. Look at the ordered pair, and then you need to flip-flop them because an inverse function switches out, it swaps your x and your y. So if we look at this point, we're over at 2, up 1, 2, 3, 4, 5, 6. So this point is going to be 2, 6. So in order to draw this point at its inverse, I'm going to flip-flop this and make it become 6, 2. Whoa. Sorry, that's horrible. Okay, so go over 1, 2, 3, 4, 5, 6, up 2. All right, this point's at 1, up 2. So then I'm going to flip-flop that and make it a 2, 1. So I'm going to go over 2, up 1. Okay, this point is at -3, -1. Oh my. So I'm going to flip-flop those, so it's -1, -3. So I'm going back to -1, down 1, 2, 3. And this last point is at -4, -6. And I want to flip-flop those, so -6, -4. So back to -6, down 1, 2, 3, 4. And then connect, and it's going to look, there we go, good, good. All right. So going down to number 3, we want to verify that these functions are inverses of each other. So there's 2 ways that you can do this. I'm going to first show how that we plug them into each other, and then I can show the other way as well. So I'm going to use f of x as a red. My g of x is going to be green. So you want to plug these functions into each other to figure out if you get the outcome of x. If so, when you plug them both into each other, then yes, they're inverses. All right, so I'm going to plug in my g of x. So instead of my x value, I'm plugging in the entire function. So -1/3 x plus 4/3. And make sure too that you're distributing them. Distribute the -3 into both of those. Okay, so this is going to leave me with 4. -3 times -1/3. Remember that 3's are going to cancel, and a negative times a negative will give you a positive x, because you would end up with a 1, but then we have our x over here. So if you want to put 1x, that's totally fine. And then negative 3 times 4/3 again. If you multiply 3, that's going to cancel this 3 at the bottom. So you're going to be left with negative 4. Okay, and then positive 4, negative 4, I'm left with an x. So now let's double check. You have to plug now f of x into your g of x function. Plus 4/3. So instead of x, we're plugging in the entire function. So 4 minus 3x. And again, make sure you're distributing and using all of your algebra. The negative 1/3 into both. So here we have 1/3, negative 1/3 times 4 will give me a negative 4/3. And then a negative 1/3 times negative 3x, that's going to make my 3's cancel. And it's going to, 2 negatives will make a positive, and I'll be left with 1x. And then out here, I have 4/3. Okay, so we have a negative and a positive. Those are going to go away, and I will be left with a positive x. So since both of these, when I plug these functions into each other, the outcome is x, yes, these are inverse functions. Okay, I'm going to just scroll up. One other way to check this would be swap your x and your y's. Okay, so let me draw this up here. Okay, so I'm going to say x equals 4 minus 3y. And now I want to isolate my y. Okay, so I'm going to subtract 4. So I'm going to have x minus 4 equals negative 3y. And now I want to divide by 3. So I'm going to divide by, negative 3. Okay, so I will be left with y equals, it's going to become a positive 4/3. And this is x over negative 3 or negative 1 over 3 x, which is exactly this function. So that's another way you can check. Check to see that once you rearrange and you swap your x and y's, that you end up with the other function. If so, then that works. All right. For 4, okay, here you need to find the inverses of each other. So you know what? I'm actually going to make a new video for 4 and then for the other pages. So I'll stop this one and I will